Okay, we will talk about, or we'll start with um, the fourth unit, and for section A, I'll simultaneously complete the third unit in meanwhile. So anyway, we will look at the topic of the fourth unit, that is graph traversal techniques. Now, for any data structure, though we are in a topic, the class of design and analysis of algorithms, but for any data structure, whether it is stack, queue, linked lists, there is certain kind of way you visit nodes. In the same way you have for trees, because trees and graphs are non-linear data structures, there is a different way of visiting nodes. In stacks, queues, and your linked list, or even arrays, how you visit is you visit nodes or you visit elements sequentially, because there is a before and after relationship. One element is after the other, another element is before one element. But graphs and trees are non-linear data structures. So they do not have the relationship of before and after. They have a hierarchical relationship. So it's not a succeeding or preceding relationship. It's a hierarchical relationship. So we need a different kind of way or method to traverse these elements or nodes of the graph or tree. Now, any way of traversing is nothing but it's a systematic procedure or systematic way of exploring the graph. Systematic way of exploring the graph in the sense visiting each node in some fashion. Now, when we visit each node in some fashion, obviously we have to visit according to how the edges are. The edges can be directed or undirected. So if it's a directed edge, obviously it has got an orientation, and we have to follow the arrow to visit one vertex to another, following the edges. Now, there can be different ways of traversing or exploring the edges, but we have to have an efficient way of traversal so that we can visit each and every node going through edges of the graph, or we can visit each and every vertex going through edges of the graph in some linear time or in some computational time. Now, there are different types of graph. For example, even undirected graph, what happens is the graph traversal is used for knowing that, which node can be visited or finding the path, and so long. Then can we reach all the nodes or not, or all the vertices or not? So if we can reach all the nodes or all the vertices, then the graph is connected. That is, every vertex can be reached from the other vertex. Then graph traversal is also used for knowing the or finding whether the graph has connected components or not. Because sometimes what happens is if one node goes down, the edges which connects the other nodes will also go down, and then there will be two different graphs. So they will have there will be a two different or more than one different component. So that is why we need graph traversals. And the last thing is to compute whether there is a cycle in the graph or not. So this is one thing. Cycle you can find, which also gives us the whether there is a path, round robin path or not. Then the last thing with respect to what are the benefits of graph traversals to find or compute this spanning tree. Now, spanning tree, remember, it's a tree, so they will not have any cycle. So that's why it's called as a tree. So these are the different, different things we can do by performing graph traversal. For directed graphs also, you can have to find, computing the direct path from one vertex to another, finding all the edges reachable from the vertex. It's the same about directed as well as undirected graph. There is only some few difference there. And determining whether the graph is strongly connected or not, whether graph is acyclic, that is whether it has cycle or not. So these things are both same for directed and the why we need graph traversals same for directed as well as undirected graphs. The only difference is directed graph will have orientation edges, undirected graph will not have orientation on edges. Now, when we move further, now there are two methods of traversing the graph. One is the breadth first search, the other one is the depth first search. So we are going to look into these two methods, or we'll try to you might have heard of these two terms, depth first search and breadth first search. So let us once again look at how these two work, that is depth first and breadth first search.